Before we're starting, sorry if I frighten any of you. Before we're starting our next set of sessions, I want to ask you if any of you has seen the kind of famous movie Back to the Future. Any of you has the feeling that applying machine technology, you're kind of able to do things ahead of their time? No? Okay. Maybe you can win lottery with that. Who knows? So we have a number of sessions today, really interesting ones. Some practical, some more theoretical, with the products, highlights, and I think we've identified a great opportunity to use machine learning to change people's lives, to make predictions or fail in predicting whether or not certain candidates will become presidents. And of course, we can make money, right? Or companies can make money. When I saw this title, Practical Applications in Medical Informatics, my first question, and I'm hoping that Johann Stan is going to be answering us pretty shortly, is this about applying machine learning in medical informatics to make money for pharma or to save lives, or both? So, Johann, the stage is yours.
Thank you. Good afternoon. Good question, actually. Challenging question, because we have to do both. If we just save lives, the company won't survive. So, yeah. I'm Johann Stan. Now, I know that this is a big question mark for you. Like, what is a guy from the European Patent Office doing at an IT conference speaking about medical informatics? Because patent examiners are legal people. So I come back a bit on this subject. Before joining the European Patent Office, where I actually work right now, I used to work for the US government in Washington, DC, and in the health department. And I was working on some very interesting projects related to a field which I think is exciting, amazing, medical informatics. So what I want to do today is to introduce a bit the field to you, show what we can do and what actually we did, like projects. What are the main questions right now the US government is trying to answer in the field of medical informatics? And of course, focusing on how machine learning is playing a very important role in the field. And I was hesitating, like, what is the best way to show this field of medical informatics? Has any of you actually heard about it or worked in medical informatics? So it's quite new for you, right? It's, I mean, I know you don't do it at school, it's at university, and maybe Romania is not very up-to-date in medical technology, in medical informatics, medical software. I will give you some examples. And I'm hoping at least that this will give you some ideas for some nice startups, because this is an exciting field. Actually, to give you an indication of how exciting the field is, you know that at the European Patent Office, every year we do statistics. Like, which are the fields which innovate the most? Like, what are the fields that apply for the most patents? And actually, for 5 years now in a row, medical informatics is the first. So we receive in this field a huge number of applications, and the European Patent Office had to hire a huge amount of people, which is not easy, because specialists in medical informatics are not easy to find. It's a bit of a, you know, difficult specialization, and I'm going to tell you why. Because you need a bit of medical knowledge in order to be performant in medical informatics. So when I joined the US government to work in medical informatics, I had to take courses in clinical pharmacology. And you can imagine, for a guy in computer science, going back to chemistry classes, because, you know, it's a nice name, clinical pharmacology, but actually it's chemistry. So you have to learn about half-lives, you have to learn about nice formulas about drugs. The easiest part is to learn, which drug is in which drug class. So if I tell you, yes?
Just to understand a bit, medical informatics is about informatics in the field of medicine, or it's a kind of informatics which is mimicking a kind of something?
No, medical informatics is medical IT, we solve medical problems with IT technology. But as I said, in order to be really good in the field, you need the medical knowledge, at least some basics.
We do have also a
Good. Where? Okay, but then I asked in the beginning, you did not.
Because I was confused about the term. This is why I asked.
Okay, so you do it. Great. Good. Let's move on a bit. I think this button. Yes. So, as I said, I was hesitating a bit how to present this field. And I decided I will pick one project we did, and I will show you from the beginning to the end how to develop completely from zero an application in the field of medical informatics. Now, what is this project about, and why did I choose this project? Well, first of all, you have to know that the US is investing a huge amount of money in improving healthcare. Not everything you hear about, the failure of Obamacare and stuff like this is true. There are billions of dollars invested in top-edge technologies. Some examples, the Brain Project, to understand, fully how the brain works. Biggest investment in improving and developing technology for structured knowledge bases, in which we have all the drugs, side effects, adverse effects, and everything related to drugs. I will show you some of these. And, of course, everything related to images, like machine learning technologies applied to CT scans, radio scans, to detect, for example, automatically if there is tuberculosis in the lungs or not. And actually the US is using these projects, the technology. They actually deploy it in countries which don't have the resources, like Kenya, to improve healthcare also in these countries. Now, what is this project about? Put it very simply. Maybe you know, but I will tell you a story which will maybe shock you a bit. It's a true story, I don't lie. What is a drug-drug interaction? It's put very simply, if you take two drugs in the same time, there are some drug combinations which you cannot take in the same time, right? Something happens. And usually something bad happens if you take some drugs together. But it's not only about drugs. There's some food that if you take with some drugs, it's also not very good. And I wanted to show you one of the biggest example, or most important food. We call it a food, it's a juice, grapefruit juice, right? So it's known that the grapefruit juice decreases the activity of the cytochrome enzymes. And because of this, actually this enzyme is needed to process some other drugs to get the active ingredient. A lot of drugs, 85 drugs. For example, some very important drugs, like calcium channel antagonists. These are for blood pressure, right? High blood pressure. Or AHMG reductase inhibitors. These drugs inhibit lipids, so it's for cholesterol. And also some other drugs. So basically, what does it mean? If you take grapefruit juice and then you take this drug, the concentration of the drug is not going to be the one which is expected, but much higher. So it stays more in the body, and then side effects will come. Bad side effects. The negative side effect of a drug is called actually adverse drug reaction, because there can be good side effects of a drug, right? Now, why am I telling you this? You may think, okay, let's be serious. You can easily solve this problem. I mean, come on, you make a database with all the known drug pairs which interact, or the food pairs which interact. And then when drug doctors prescribe drugs, or you go to the pharmacy to get a drug prescription, if for some reason the two of the drugs which are on the list, on the prescription, interact, it will get triggered an alert. Right? I mean, is it that complicated to come up with a list of all the drug pairs which interact?
Yes, because there are quite a lot of drugs that you usually take, and also sometimes it's happened that the same drug is can be found with different concentration and different names, and also usually patients don't report exactly what they happen. So you usually find out much later that something wrong happened, and it's hard to figure out what did he take, because, for example, graphic juice might be something that you will ask for it, but maybe he takes something completely different, and he will usually take, and you don't think ask about it. So I believe it's very hard.
I like the answer. Yes, it's very hard. But maybe for people in IT, I mean, thinking from a technology point of view, it's not that hard. From a medical point of view, of course, it's very hard. And let's look at some data. I don't know why this image came up. Well, people still die from drug interactions. And here comes the story. I have a friend in Regin. Regin is not far from here, actually. And I was working for the US government precisely on this project in 2014. And this guy had an accident, car accident. So he was taken to ER and he got some prescription drugs after the treatment, right, for preventing some things to happen in the body, like, this blood coagulation issues. And he calls me that, hey, I'm not feeling well, I'm always dizzy. But this was much later after the accident. So I was asking him, okay, what did you get as a drugs? Show me the list. So he gave me the list, and then I looked at it. Well, these were two interacting pairs that in the US, if a doctor prescribed them, he would go to jail immediately. And then I started actually to ask friends who are doctors, do you know about drug interactions? Or pharmacists, because I have some friends in the field. Well, yes and no, yes and no. We don't really pay attention. We don't really tell patients that you should not drink grapefruit juice with this specific drug. Then I asked, family members, because some older people, of course, suffer from high blood pressure. Do you know you should not take grapefruit juice? And actually, in my family, I identified one person who very actively drank grapefruit juice while taking the this calcium channel blocker. So it's a big issue, but not only in Romania that there are problems. As you can see in these statistics, drug-drug interactions represent from 3 to 5% of preventable in-hospital adverse drug reactions. Another study showed that 1 to 2% of hospital admissions were related to drug-drug interactions. Now, okay, this is a medical problem. As you mentioned, it's difficult. But then we were thinking about, could software solve this problem? At least improve the situation. What does it mean? As I mentioned before, could a comprehensive database which contains at least most of the known drug-drug interaction pairs, because this is between two elements, right? You have the object. The object is something you take a calcium channel blocker, and then you have a so-called second entity you take into your body, the precipitant, which modifies the object. This would be, in our case, the grapefruit juice, right? You drink it just right after you took the high blood pressure drug, and then everything goes wrong because you cannot anticipate anymore the concentration of the drug or the half-life of the drug. So, of course, other people also had this idea to build software which, solve this problem. But, so, of course, people started working on it. And as you can see, this observation was made quite some time ago, 17 years actually. So we would expect that with the current technology, we have now all the resources required to detect drug-drug interactions, either you buy some drugs, you go home, you like make inputs in a system, I don't know, like a Google-based engine. You put the two drug names and it will trigger either red or green, right? That's the least thing we expect. Now, what do you think? Is this problem solved? Can I just go online, put the two drugs in a system? Do you know about such a system? Are you concerned about it? Like, do you check usually if the drugs you get are interacting or not? Well, probably not that much, right? Because we expect the doctor would tell us or the pharmacist would tell us, but I recommend you to check it because you can have issues like my friend in Reagan. Well, that's now a big lawsuit actually, which is going on. But I will present you now a situation which is not very happy. And this is in the US, so we go to the US now. Why do we go to the US? Because in Romania there are no resources about drug-drug interactions, so I cannot use any online system where I would be able to query about drug interactions. However, the US government decided a few years ago, it's called the FDA, the Federal Drug Administration. So if you go to Washington, D.C., it's just in front of the health department, a huge building, that every drug labels are, you know, those papers you get in the box with the drug. And usually we throw them away immediately because it's painful, you know, when you open the drug, it's always there, so you just throw it away. Sometimes it's good to read them, but, you know, I also throw them away usually. Like, why would you check the drug label for Advil, you know, ibuprofen? Well, I checked it once, and there are some surprising interactions that maybe you should know about. Okay, so, yes?
Sorry, why are the letters so small on this?
If I worked for a pharmacy company, I would probably be able to tell you, but yeah, I mean, the reason is simple. It's a lot of information, and otherwise it would not fit in the box, right? But I agree with you, and actually the US government is working on this, that some parts at least should be highlighted. Some parts. Like, for example, those interactions which lead to death, because there are various types of drug interactions. But we'll go to this soon. What I want to say here is that there are actually lots of databases online which contain drug interactions. I mean, you know, any doctor can start building his or her own database, or any pharmacy company or an NGO could, you know, just build a database, or a public institution, like, for example, NDFRT, which is the biggest database in the US about drug interactions, is built by the Veterans Association. So they built a database where doctors treating the veterans can, you know, quickly get resources. The veterans play a very important role in American society, so they have lots of resources. Or we have Drug Bank. Drug Bank is a resource which was built by Canada, also about drug interactions. Or, you know, CLEG. CLEG is a database built by Japanese, so it's about Japanese drugs and interactions. Or we have lots of so-called corpora that have been built for machine learning tasks, you know, training data. And of course, one would expect that, okay, if we have so many resources, I identified here only 14, but there are many. Actually, I neglected some of the most important. But let's say that we have some which are very important. So NDFRT, Drug Bank, DailyMed, which is built by the National Library of Medicine. So what would we expect if we have so many resources that they overlap? So if I have a drug interaction pair, I don't know, grapefruit juice with verapamil, right? Then I would find them in and it's an important drug interaction pair, that I would find them, right, in most of these databases, or at least in the most important ones. Well, I want to show you the reality, because of course, if we check a bit the description of these data sources, as I said, we have, okay, I actually have 13. I thought I had 14, but it's 13. You know, some of these databases are for clinical applications. What does it mean? It means that these data sources are actually used by systems that doctors have in the US. So you go to the doctor, he thinks you need a set of drugs, and he will put them in the system, and if there's an interaction, there will be an alerting mechanism, okay? This is what clinical application means. Now, some of the resources, as I said, are only for you know, research purposes. So you use them for training machine learning algorithms. Like we want to build a new machine learning method or a new machine learning software, I mean based on machine learning, which automatically detects drug interactions in text. So you need training data. And of course, some people build some very comprehensive resources for, yes?
I'm sorry, I have a pretty stupid question, but I'm curious. Are these resources freely available or are they?
All of them are free, so you can check it online. Download it. If I have internet, I want to show you one of them, but there were issues with the internet, so I'm not really confident. I don't know whom we have to pray to have internet. So some of them are only for machine learning. What does it mean? It means that if a doctor would use, for example, DDY Corpus 2011, this was actually built for a big machine learning competition. So, you know, teams all over the world could submit their solutions to automatically extract drug interactions from text. So if the doctor would use this in a patient setting, so, you know, to check if the prescription, you know, is interacting or not, it's not allowed. So he would be, of course, prosecuted. And then, of course, there are some resources for so-called bioinformatics applications, but the most important thing to remember is that only these resources were validated by the FDA, so the Federal Drug Administration, to be used in clinical settings. So in advising patients, okay, don't drink grapefruit juice because this will happen. Now, the first question I want to show you, I mean, is that these sources actually do not really overlap. So what does it mean? If I'm a patient and I receive a prescription, so I want to check if everything is all right. Like, did the doctor forget something? What should I not eat with these drugs? What should I not drink with these drugs? I actually don't have one single reliable resource to check this information. Because, and I will skip a bit the technical part, this was a study we did with all of these resources to see how well they overlap. Overlap means you take one of the resources and you want to check how many of the interactions are present in a second resource. Now, in order to compute overlaps between databases, this is a semantic web related problem. You have to map them, right? And how do you do mappings between two data sources? You have several possibilities. Maybe one of the data sources has direct references to another one, links, pointers. This is, for example, with drug bank. In drug bank, they have references to CLEG, so this means that some people manually inserted in the database the corresponding identifiers from CLEG. So we have a direct connection. Sometimes you don't have this. And then what you have to do is string matching. So you have a drug name in one of the resource, but maybe in another data source, like because it's a different country or a different terminology, it will be a different name, but you still have to try to do some matching. And then you have to define thresholds based on your level of precision you want. So we did all of this study, and it came out that the largest overlap in terms of drug-drug interaction count, was between drug bank and KEG, so the Japanese and the Canadian resources. But still quite a few drug interactions overlapped. Also, drug bank and KEG cover the most drug pairs across all the resources. So I would say these are the two most reliable ones, or comprehensive. But here are some problems. No drug interaction was common to all resources. Not even the most critical ones, like, you take 2 drugs, you die immediately. No, they're not present in all of them. Only 4 drug interactions, these are very dangerous drug interactions, were common to the bioinformatics and pharmacovigilance sources, which are used for building software. Now, also, this ONC high priority, this is quite important because this is a list of 20 drug interactions, 24, which are like really critical. So every doctor in the US and in the world should know about them. But only these were present in NDFRT and ONC high plane and in the OSCAR. So that's another resource. Even comprehensive drug-drug interaction lists, such as I mentioned, drug bank, KEG, and NDFRT, had less than 50% overlap. So you can go online, you can check these resources. I think if, I don't know if there are university professors here in the room, but this is, I think these projects to compute these mappings and build medical informatics applications are nice projects for students. So I had some students, of course, and we did some nice projects with this. I will show you one of them soon. But what I want to show you here is really that it's a big, big problem that these resources don't overlap. And despite the fact that you can die from this drug interaction if you don't know about it, we don't really have a reliable resource to check them. And we are, in 2017, we are able to land on comets. Like here you have this nice image in Philly, but there are some problems we are still haven't solved. And this is America. Now, the situation in Romania is even worse. We have nothing. I mean, you have to say it as it is. I checked. I wrote some emails to the government. I have some friends there. We have nothing. So, yes.
Any answer from the government?
Well, no, they never replied, but my friend told me that, yes, indeed, we don't have these structured product labels. So what does it mean, the structured product label? What we have in Romania is, for every drug label, so these are all the drugs which are on the market, they upload the PDF. But the PDF you cannot really do advanced natural language processing. So what America has, and I send them the format because it's everything is open. They have every drug label in XML in a structured way. So you can do advanced machine learning natural language processing. And this is actually the next part of my presentation because here I wanted to show you a bit the context. Why is it important to work on these projects in medical informatics? Because people still die from it. I mean, from mistakes, and they don't have the right source to check, right? So I think we as people in IT, it's something important to work on it because you can save lives. I myself like to work on projects which are meaningful, and I think this is something meaningful. And now you know that Romania has no such resources, so why not build some of them? I mean, you can make history. Like, why not build the first database with structured product labels in Romania? Of course, you would need a huge team because, to transform all of those PDFs in XML. It's not easy, and then to develop the database. But, why should we work on easy projects, right? And of course, as I said, for me, this was the most shocking observation that even those 20 critical drug interaction pairs had low coverage in the biggest resources. So this is a so-called structured product label. These are published by DailyMed. DailyMed is the medical database of the US government. It's hosted by the National Library of Medicine, which is the research institution of the health department. So in the US, the health department has its own research institution. They have about 400 scientists, and they're working on various projects in medical informatics. Some of them I mentioned in the beginning, like, everything about building these data sources, improving them, because, you saw now how low the overlap is. So now actually one of the biggest projects they're trying to do is to create at last a complete data source which is reliable and which contains all the critical drug interactions. But what information do we have in a structured product label? Of course, everything about the composition of the drug. This is the description, the clinical pharmacology. This is, the half-life of the drug, concentrations, various concentration, like for kids, for pregnant people, for elderly people. Indication and usage. This is, of course, why should you take it? How should you take it? Contraindications. So if you have a given health issue, you should not take the given drug. Warnings. Warnings are like, you should not keep the drug on high temperature. Now, the most important part is adverse reactions. Adverse reaction is a term in clinical pharmacology which means negative side effects. An adverse reaction can occur if you take the drug in its normal dosage, but you do something else. So you take another drug, and then they interact, because one of them maybe inhibits some of the enzymes which are needed to get the active ingredient of the other. So what we wanted to do is to download all of these structured product labels and to develop a machine learning framework which automatically extracts all the drug interactions. So the drug interaction is usually expressed in a sentence. Do not take verapamil with grapefruit juice, right? This is a sentence. A drug interaction has always two entities. It's between two drugs, or a food and a drug. So this was a natural language processing problem also. And in the next few slides, I will show you how we did the project. Now, there were many talks today and about machine learning, so I will not focus on it. I will directly go into the details. This is a supervised problem, right? Supervised learning problem. So the first thing you have to do is to build training data. Now, a few things about building training data. I think this is quite important. How you do training data. Training data means that you have pre-classified data, right? And you have to have them correctly classified because you will use them to train your model. So we don't have a comprehensive resource where we can get all the drugs belonging to a drug class. This is also not overlapping between the available drug resources. So I think we have to wait a few more years to get some, high precision tools. But anyway, I wanted to show you the framework. I focused a lot on the creating the training data because I think this is a part of machine learning we often neglect. And it's quite important, like how to build reliable, high-quality training data. So remember that we need really several annotators, a good model, and to compute the scores, inter-annotator agreement. And then, of course, how to develop the entire framework. Thank you.
Thank you, Johann. Okay, our next speaker is going to set the stage. I think we still have time for 2 questions, so if anybody from the audience. Okay, we have two questions. Okay?
The resources that you were mentioning, are they exported to the public APIs that you can automatically pass what data? It's like Google and
Yes, so you have, for example, MetaMap, which is a tool developed by us. I was part of the team. You submit a text, and it will automatically give you back the drug names in the text. So we have such resources which help in the process.
I was referring to the resources that are outlining the API.
Yeah.
So if they are exposing an API, you can build a tool which can trigger.
Yeah, that's what we did, of course. So drug bank is an API, so you can, of course, yes.
Okay, next question was over there. Okay.
Yeah, okay, so this is just related to yeah, you said you were for the US government. What are their plans in using maybe nanotechnology?
In what technology?
Nanotechnology, the box, for example, if a person drinks the juice, and it will be alerted that they don't want to drink that because different.
Yeah, so one obvious application is that this system is available for drug doctors and in the pharmacy. So when you get the prescription, they check it and they get the alert. But then, I quit the government already, but I know that they are now working on mobile applications where patients can get the alerts in any kind of real life situation.
Okay, another one.
Just another question. Basically, how do you think it would shape up the insurance business? Because, to be honest, I fail to see how applying basically machine learning and distributed computing would help the consumer in the fields of insurance. If you know what I mean. Basically, getting a stream of data, processing them, and then seeing, okay, you have, let's say, 80% of incurring, let's say, cancer in the next 20 years, so we're not going to insure you.
Okay, yeah, this is a bit deviating from the topic. What insurance companies do, let's take the example of driving. So now you have these black boxes in cars. They check your driving style and they predict how reliable or how dangerously you drive, and they adjust the fee automatically month by month. Like in the summer, you go more often to the mountains, it's more dangerous, so you pay more. In winter, you go always to work because it's always raining and stuff. You pay less because it's always the same route. Now, in the medical field, I think it's something exactly the same. Like I already know about projects or initiatives that they check how often you go to the gym in a month, which means that month you pay less insurance because you had a healthy lifestyle. But in the next month you go often to McDonald's, you pay more. So this flexible rate, I think, is what is really coming.
Okay.